All right, so now I'm going to do a little example circuit here. You should have some sort of background in computer science if you're watching this, as I mentioned already, but you probably won't have an electrical engineering background. I know I certainly didn't. This is usually not something you're going to have to worry about with your Arduino. I usually power mine with a USB, in which case it's fine. And if you use the voltage in pin, you can have anything up to 12 volts. It should regulate the amount of power going to the Arduino, so you don't have to worry specifically about how much power is going to it. But if you have something a little bit more fragile and simple like an LED, it's not going to have this built in, and if you give it too much power, it'll burn it out and break, and then you can't use it anymore, which obviously is not what you want. So I want to do a little example here of trying to find a sweet spot of knowing how much power to give this and how to pull that off. So for my example here, I have this formula R, that's the resistance you're adding. So with a resistor, as I mentioned earlier, they come in a lot of different kinds. And they're measured in ohms, which you'll see will be this symbol. So you can get them from 5 ohms to like 5,000 ohms. There's a huge range of different values that these resistors can be. So when you're making a circuit, you want to find out how much resistance you need, and then you're going to find a resistor that's has that many ohms, and that's going to allow your circuit to function properly without completely destroying the LED. So that's the R, that's the resistance, but we usually want to find that because we know the other information. So I want to do this example here. If I have a battery here that's 3 volts, I connect the positive terminal to the longer leg of the LED because that's the positive LED leg, and for an LED, the current can only flow through it one way. And if I'm going to put a resistor here, which is denoted like this, that's a resistor. That's going to be this R. The voltage supplied is going to be this, the 3 volts. So I can put a 3 volts here, and then minus the voltage needed times the number of LEDs you have. So for here, looking at these red LEDs, I generally know this, but I just looked up one on eBay. They usually need about 2 volts at 20 milliamps. So I can go ahead and put my 2 volts here in the formula, minus, and then I only have 1, so times 1, pretty easy. The other thing to note here is a lot of the time it's measured in milliamps, right? Which is 1,000th of an amp. So if I want to convert this into amps for the formula, I need to divide it by 1,000, and I get 0.02 amps. Cool. And then I put that in the formula right here under the current needed from the LED, right? So we're getting 3 minus 2 times 1. This is just 2. And then 3 minus 2 is 1. So it's 1 divided by 0.02. And if we multiply the top and bottom by this by 50, then we get 50 over 1. So we know the resistance that we need for the circuit is 50 ohms, just like this. There's also a ton of calculators online that will do all this for you. Just look up LED calculator, and then you can give it the same information that I had for this problem, and it'll tell you exactly how much current you need. And then it also depends if you set them up in parallel or in series. Obviously that changes either the voltage or the current, so that's something else to think about. And then this negative leg has to come back to the negative terminal of the battery, and then this will turn on and be fine. The other thing is this is like the recommended current, but if you want to get a little fancy with it, you can either change this from the Arduino or with the resistors. If you give it more resistance than this, then it will get less bright until a point there's so much resistance that not enough current is going through it to turn it on. So it's an interesting way to dim the LEDs to give it more resistance. And that, of course, is going to restrict some of the power going to it, which is going to make it a little duller until eventually you get to the cutoff point. Also, this isn't strictly for LEDs. Most modules will have a voltage regulator if they're on a board. So again, it depends on the module. I'd look into it. Like it'll tell you it's recommended 5 volts, but really the device itself doesn't need 5 volts, but it has a regulator so that it's really giving the board exactly how much it needs as long as you give it 5 volts. But for anything else that does not have a regulator in it, It's the same as just for this LED. You use the same formula. There's also a lot of calculators online. There's also a lot of tutorials online. And I would recommend that you just do your research before you wire stuff together. Because I can tell you my first thing I ever did when I was working on an electronics project was take a 3-volt battery and go, oh, this is an LED. I should just wire it all together. And poof, the LED just instantly burnt out. And I didn't have an LED after that. So something to keep in mind, just if you're following a tutorial, read the steps. Don't skip steps with this because this is how you end up damaging equipment that's not already protected.